Hello everyone and welcome back to my YouTube channel. Today we will discuss quantum numbers for class +1 chemistry. It is most important and let's back to the Bohr model. Bohr said that electrons revolve in a stationary path called orbit. Bohr concluded that electrons revolve around nucleus in a circular path. Those circular paths are called orbits. But when quantum model of atom came into existence, then later on we found it that each orbit contains subshells. Each orbit contains subshells, and each subshells has orbitals. So finally, electrons are present in orbitals. They are spinning in orbitals. Each orbit or shell has subshells, and each subshell has orbitals. Easy. So finally, we can say atom contains orbit. Orbit contains subshells, and subshell contains orbitals. This is the correct sequence. Each atom has orbitals in which electrons are present, or they are spinning, or they are oriented. Easy. So to understand these orbitals, we must know quantum numbers. So what is this quantum number? Quantum numbers are actually set of four numbers which provide us the exact information about electrons. And what can we add in this information? Their spin, shape of orbital, energy of orbital, energy of electron, size of shell, their angular momentum, so all the necessary informations are provided by these set of four numbers. These numbers are called quantum numbers. Easy. So let's start one by one. First quantum number is principal quantum number, denoted by small n. Principal quantum number denoted by small n, and it was discovered given by Bohr. Bohr has introduced first quantum number, principal quantum number. By knowing this n principal quantum number, we can obtain these results. What information we can obtain, or what results we can obtain by using this n. First is number of shell. For example, n equal to 1, 2, 3, 4, and so on. So, and Bohr introduced K, L, M, and N. So shells are represented by this principal quantum number. Second, total number of electrons in any shell can be calculated by simple formula 2n square. And we have discussed already, first shell contains 2 electrons, second shell contains 8 electrons, third shell contains 18 electrons, and fourth shell contains 32 electrons. Easy. Third, radius of orbit, and we have the formula 0.529 into n square by z angstrom. So by putting the value of n, even we can find out the radius of orbit. Z represents the atomic number of atom. For energy of orbit, minus 13.6 into z square by n square electron volt per atom. Here we can see again To find the energy we need n, and n is a principal quantum number. Next, fifth is number of subshells present in any shell equal to n. Each shell contains subshells, and if we know the value of n, we can find out the number of subshells also. For example, n equal to 1 subshell 1, n equal to 2 subshells 2, n equal to 3 subshell 3, n equal to 4 subshells 4. So number of subshells present in any atom are simply founded by putting the value of n. So we can say K shell contain 1 subshell, L shell contains 2 subshell, M shell contains 3 subshells, and N shell contains 4 subshells. Easy. Sixth is number of orbitals present in shell can be found by using n square. Number of orbitals present in shell can be found by using n square. Easy. These are the 6 major results we can obtain by using principal quantum number n. Easy. Next is second is azimuthal quantum number, or it is also known as angular momentum quantum number, denoted by small l. Angular quantum number or azimuthal quantum number, denoted by L. It was discovered or given by Sommerfeld. It was given by Sommerfeld. By knowing the azimuthal quantum number, we can find out the angular momentum of electron. Second, we can find out the shape of orbitals present in a subshell. Third, this L describes the number of subshells. Number of subshells, and mathematically it is equal to L equal to 0 to n minus 1. L equal to 0 to n minus 1. Let's put the value of n and find out how many subshells are present in a shell. If n equal to 1, possible values of L 0. If n equal to 2, possible values of L 0 to n minus 1, 2 minus 1. N equal to 3, possible values are 0, 1, 2. We are using 0 to n minus 1. N equal to 4, N equal to 0, 1, 2, 3. So 4 shall contain 4 subshell. First shall contain 1 subshell, second shall contain 2 subshells, third contains 3. And we design the subshell's name. If L equal to 0, that subshell is S subshell. If L equal to 1, subshell name is P subshell. L equal to 2, subshell name is D. If L equal to 3, subshell is F subshell. And if L equal to 4, shell is G subshell, and so on. Is it? So let's use these names here. So we can say n equal to 1, n equal to 0. It means this is 1s. 1 represents principal quantum number, shell number. S represents a shell number, yeah, or simply subshell. N equal to 2. So we can use 0 stand for S, 2s, 1, 2p. Second shell contains 2 subshell, 2s and 2p. Now comes to third, n equal to 3, n is 0 means it is a, I saw here, n equal to 0, 1, 2 means 3s, 3p and 3d. 2 is a d subshell. Easy. So similarly we can solve for 4. This is 4s, 4p, 4d and f. Why? Because 3 is a f sub shell. Easy. So this L basically describe the subshells, and from there these words comes. S comes from sharp, P comes from principal, D comes from diffuse, F comes from a fundamental particles obtained from a spectrum. S sharp, P principal, D diffuse, F fundamental. Simple. So this is a azimuthal quantum number which tells us about the subshells, how many subshells and what are their names. For example, again 4 shall contain 4 subshells, 4s, 4p, 4d and 4f. Now third quantum number. Third quantum number is magnetic quantum number denoted by small m. Magnetic quantum number, as its names indicate, it will tell us the magnetic behavior of an atom. As we know, electrons revolve in orbital path. It will produce electric field, and due to electric field, magnetic field will also produce. That is electromagnetic induction. Due to electric field, magnetic field also produce, and under the influence of external magnetic field, spin and orientation of electron can be affected. So this magnetic quantum number describes the magnetic behavior, or it gives us the orbitals information. Orbital information means number of orientation of electron, and it was given by Zeeman, discovered by JEE. So this M basically gives us a number of orbitals. Number of orbitals stands for a number of orientation of electrons. How many ways of orientation of electrons? Easy. So how to find out this M? M is equal to minus L2 plus L. M here is minus L2 plus L. So if we say L equal to 0, M will be 0. If L equal to 1, M equal to minus L2 plus L, minus 1, 0, plus 1. If L equal to 2, M will be minus 2, minus 1, 0, plus 1, plus 2. If L equal to 3, M equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So what can we conclude from here? L0 means as subshell, and M value is only 1, value 0, but it is only 1 digit, so 1 orbital. So S subshell contain 1 orbital. L equal to 1, 1 is P subshell. P subshell contain 3 orbitals, minus 1, 0 and plus 1, and they are oriented in 3 axes, so their name are px, py, and pz. L equal to 2, 2 stands for d, so d sub shall contain 5 orbitals, and those orbitals are -2, -1, 0, +1, and +2. Later on we will design the name also. L equal to 3, 3 stands for F sub shell. F sub shell contain 7 orbitals. You can count. These are the 7 numbers: 1, 2, 3, 4, 5, 6, 7. So what we concluded? S sub shell contain 1 orbital. P sub shell contain 3 orbitals. D sub shell contains 5 orbitals, and F sub shell contains 7 orbitals. This is the basic conclusion obtained from a magnetic quantum number. Clear? From n principal quantum number we obtain shell number, from azimuthal quantum number L we obtain subshell, and from magnetic quantum number we obtain the orbitals. Easy. Now fourth is a spin quantum number, denoted by small s or ms. Fourth is a spin quantum number s or ms. It was given by Goldsmith and Uhlenbeck. They proposed the fourth quantum number, that is a spin quantum number. As we know, electrons revolve around nucleus in its orbital path, and it also revolves around its common axis. So electron can have two types of rotation: anti-clockwise rotation and clockwise rotation. So spin quantum number represents the orientation of electron, its spin, either it is rotating in clockwise or anti-clockwise. So we use two terms for clockwise rotation. Half is used, positive half, and anti-clockwise rotation we use minus half. So we can conclude from here only 2 electrons can present in any orbital. One spin is clockwise and other spin is anti-clockwise. Clear? This is a fourth quantum number, spin quantum number. Now let's connect all the 4 quantum number again. N, L, M, N principal quantum number, L azimuthal quantum number, M magnetic quantum number, S spin quantum number. L we find 0 to n minus 1, M is minus L2 plus L. Simple. Let's solve it for every shell. N is 1, means K shell. L 0 to n minus 1, so L is 0. M minus L to L plus L, this is again 0. So what does this basically represent? L0 means S, M0 means one value, one orbital, and one orbital can have 2 electrons. So it is either positive or negative, means clockwise or anti-clockwise. So complete representation is 1s2, 1 principal quantum number, 1 shell, S subshell. subshell contains one orbital, and in that orbital 2 electrons are present. Easy. Next, second shell, L shell. Possible values of L: 0, n minus 1, 1, 2 minus 1, 1. For 0, m is 0, 1 is plus 1, 0, minus. So what does this basically represent? 2s 2p means second shell contains 2 subshells, that are, those are 2s and 2p. S has one orbital and their spin will be positive half and negative. So half of electrons will rotate clockwise, half of electrons will rotate anti-clockwise. So we can give them the name again: 2s square and 2s2 or 2p6. 3 orbitals and each orbital contain 2 electrons. So complete will be 2p6. Second shell contains 8 electrons total, but in 2 different subshells. In 2 electrons are in 2s shell and subshell, and 6 electrons are present in a p subshell. Clear? Third, m shell, L 0, 1, 2. For 0, m value 0, plus 1, minus 1, plus 1, 0, minus 1. For 2, minus 2, minus 1, 0, plus 1, plus 2. So we can give them name again: third shell. Third shell contain 3 subshell: L0, 3s, L1, 3p, L2, 3d. Easy. And subshell S has a 1 orbital, p has 3 orbitals, and d has 5 orbitals. So total number of electrons will be 18. 6 electrons in p subshell and electrons are present in d subshell. D subshell has 5 orbitals, and 5 orbitals means each orbital can contain 2 electrons. So total number of electron 10. We can count 10, 16 plus 2, 18 electrons, and half of them will rotate clockwise and half of them will rotate anti-clockwise. Easy. Fourth, n subshell, sorry, n shell. Subshells are 0, 1, 2, 3. We can give them name: 4s, 4p, 4d, and 4f. And values of m: for s 0, for 1 minus 1, 0, plus 1, for 2 and for d minus 2, minus 1, 0, plus 1, plus 2, for 3 minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. So we can see again how many orbitals. S subshell contains 1 orbital, p subshell contains 3 orbitals, d subshell contains 5 orbitals, and f subshell contains 7 orbitals. Each orbital will contain 2 electrons. So configuration will be for this: 4s square, 4s2, 4p 6, 4d 10, and 4f 14. We can count the electron again: 14, 10, 24, 6, 30 plus 2, 32. As we know, 32 electrons are present in a fourth shell, that is n shell. So out of 32, 16 will rotate clockwise, 16 will rotate anti-clockwise. So now we have the orbitals: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, and 4f14. Easy. Similarly, we can solve for 5, 6, 7, and 8, so on. That is the importance of 4 quantum numbers that provide us shell, subshell, and orbitals, and number of electrons present in every orbital. We will use them to write the electronic configuration of elements. Easy. Let's have some tricks as a summary. For only competitive exams. First is number of electrons present in shell, 2n square. Number of electrons present in any shell, 2n square. Second, number of subshells in any shell. And third, number of orbitals in any shell, n square. Fourth, number of orbitals in subshell. Number of orbitals in a subshell, that is a 2l plus 1. Number of orbitals in subshell equal to 2l plus 1. Fifth, number of electrons in subshell, 2 into 2l plus 1. Easy. These 5 can be used to solve the questions in a competitive exam. That's it for a quantum number. In next lecture we will write the electronic configuration and some rules related to electronic configuration. Stay at home, keep learning. Do a favor, if you still didn't subscribe my channel, subscribe it for further videos. Thank you.